Okay, welcome to Strong Tree Academy, problem number 29 from the finals review packet. Here we are asked to find the eccentricity of this given conic section by this, and then remember this equation is called general form. So the first thing is we're asked what kind of conic section is it, how is it oriented, and we're also going to find its eccentricity. Well, remember the way we can easily identify what kind of conic section it is for conics in general form is to just take a look at the coefficients of the quadratic terms, the x squared and the y squared, and we can think about the signs here. So we see that the coefficient for both these guys is positive, so that tells us it's going to be either a circle or an ellipse. And if you recall, circles only happen when the coefficients themselves are actually the same number. So just by inspecting the coefficients here, we can already tell it's going to be an ellipse. We don't know yet quite how it's oriented. We have to actually put it in the standard form. So that's the main gist of this problem, is to go ahead and just factor it and complete the square. So let's go ahead and do that. So the way I like to do that is, first thing I do is collect all the x terms together. So I got the x squared, 2x squared plus 4x, collect the y terms together, 3y squared minus 6y, and then put this constant off to the other side, but it looks like it's already there. Alright, now I'm going to go ahead and set up for completing the square here. So in order to complete the square, I like to factor out the coefficient of the squared term. So I'm going to factor out the 2 here, x squared, so I have to remember to do that on the 4x as well. And I'm going to leave some space for completing the square here. So I can just check 2 times x squared is the 2x squared, 2 times 2x is 4x. Looks like I did that okay. And then I'm going to do the same thing here. Now I see there's a 3 in front of the y squared. I'm going to go ahead and factor that out. Y squared, and I'm left, when I factor the 3 out of the 6y, I'm left with 2y. I'm going to leave a little space for completing the square. And we have 13 over here. So now I'm all set and ready to go here. So how do I complete the square in this one? Well, I take that b coefficient of 2, divide it in half, which is 1, and square it. So it's basically, that's the rule, is I'll even write it over here just as a little review. Take 1/2 and square it. That's how you complete the square. So 1/2 of 2 is 1, squared is 1. Now I have to add something off to this side. And I have to always remember to multiply by that guy here. So I'm going to, just to be clear, what I'm doing here is I actually added 2 to the side by doing this. I added 1 here, but when I multiply it by 2, I've added 2. So I'm just, to make it clear, I've added 2 times 1 to that side. Now here to complete the square, I take half, which is -1, square it. -1 times -1 is +1, so that's how I complete the square. And then here, I'm multiplying by 3, so I have to multiply 3 times 1 on this side. And that gives me 13 plus 2 is 15, plus 3 is 18. Okay, now I can just go ahead and rewrite this as completed square factors. 2 times x plus 1 squared plus 3 times y minus 1 squared equals 18. And if you're not really confident what you did here, you could always re-multiply these factors out to see if you got this exact thing. I won't do that here. Now remember, standard form conic, I have to do something about this 18. I need to have that be equal to 1 in order to make this. So in order to make it in standard form, I'm just going to divide everything here by 18. And then the 2 cancels out on top. 9, the 3 cancels out on top, leaving 6 equals 1. Now I'm in business. This thing is in standard form. We can see that it's an ellipse, which we already predicted. And then it's asked how it's oriented. Well, we have to see where is the major radius here. Well, we can see that the x dimension is the larger, and so a is going to be square root of 9 or 3, and so it's going to be oriented. Well, we can see the center will be at -1, 1, and it's going to be more oriented this way. Here I've just thrown the graph into Desmos to convince ourselves that we did it right here. And so I just typed in the equation as stated on the problem. And you can see that we have an east-west oriented ellipse with the center at -1 and 1. Okay, so on to 30A. So 30A, we're just asked to sketch and identify the parts of these conic sections. Well, first thing is we just want to check out what conic section we're looking at. Well, here we see that the signs of the x squared and the y squared are opposite, so we know we're working with a hyperbola. It's positive in the x dimension, so we know it's going to kind of look this way. It's going to open up east-west. It opens up positive along it opens up along the positive dimension. We can easily see the center here. The center, you can think of these as x minus 0 squared, y minus 0 squared. So the center is going to be 0, 0. And let's get A and B off of these things too. So we know that the major radius is, again, with hyperbola always goes with the positive. It happens to be the bigger one in this case, but remember with hyperbolas, the major diameter always connects the vertices. And so we can see A squared will be the 25, which means A will be 5. And then B we can think of that as divided by 1. So B squared equals 1, which means B equals 1. And we're asked to include the foci in our sketch too, so we're going to need to have C. Remember, for hyperbolas, the relationship between A squared, B squared, and C squared is the foci are outside the box, so C squared is going to be the biggest of the two, and so that's how I like to remember the fact that it's this relationship as opposed to the ellipse version. And so C squared is going to be 25 plus 1 equals 26. So C will be root 26. Okay, I've drawn 2 lines here just to help out with the sketch because that's where we're at right now. Okay, so we have the center. We'll go ahead and draw that in right there. Label that the center. We have A is 5. So remember, this is how we draw a box in which side the little ellipse could fit. That's another way we thought about that. Remember, we changed that to a positive sign. But again, A is 5 is opening up east-west, so we're just going to tick off 5 units in this direction, 5 units in this direction, and that's going to be our vertices. Draw those in red here. We'll do the hyperbola in red. That's V1, that's V2, and if we're going to write those points off to the side, we can just write them as, I'm going to write them here as plus or minus 5, 0. Okay, now we got to draw our hyperbola box. V is 1, so we're just going to go up 1 unit. And that gives us everything we need to draw what I like to call the hyperbola box. And remember, if we change this to an ellipse, we can see that the ellipse that would be here if we made that positive was what would fit inside this box. That's how I like to remember it. I'm not going to really draw that right now. Except I drew this box wrong. Sorry about that. Got to go out to the vertex. Okay, and then we also need to get the asymptotes. Remember, the asymptotes go through the corner of the box. I'm going to go ahead and draw these guys in green. Hopefully I can do this okay on this tablet. Might be a little hard. Yeah, it's not the greatest asymptote, but you get the idea. And the other one's going to go through the box as well. Corners of the box. Wow, that's really not so good. Well, anyway, so that's the sketch, and now we have everything we need to finish off the sketch. The hyperbola is going to approach those asymptotes. Again, when you draw this, make sure you try and make that happen. Make the hyperbola actually get closer and closer to your asymptotes that you drew. And it looks like that's not a bad representation. Now we just need to put the foci in. I'll do that in blue here. C is, remember, the distance between the center and the focus is going to be C. That's going to be root 26, which is a little greater than 5. So the foci looks like it's going to be about right here and about right here. That's a little past 5. Call that F2, F1. We're going to write those over here. The foci would be plus or minus root 26, 0. We're just going out root 26 from each side. Then the last thing we might want to know here is what are the equations of these green asymptotes. Well, there's just you need the slope and you need a point on the line. So a point we know on the line is going to be 0, 0. And we know the slope here is just rise over run within this box. Well, the rise of the box is, I'm going to actually just look at this little box. The rise of the box is actually 2. I'll do that. Slope is going to be 2. And the run of the box is 2 times A, which is 10, which equals 1/5. And then there's a plus and minus version of it, right? This is the positive slope asymptote. This is the negative slope asymptote. So I'm going to put a plus or minus there. And so to write the equations, I'm just going to do point slope form. Y minus 0 equals plus or minus 1/5 x minus 0. And if you wanted to write them separately, you would just write y equals 1/5 x, y equals negative 1/5 x. Okay, 30b. Here we have an equation. It looks like it's going to be an ellipse because we have 2 positive terms. We just have to put this first into standard form by dividing through by 36. Sorry about the colors there. And that will give us x minus 1 squared over 9 plus y plus 1 squared. So y over 4 equals 1. Okay, so now to sketch this, I've just gone on and drawn the graph here. We need, or drawn some axes here. We need to get all our pieces. So the major radius is going to be the larger of the 2 numbers here. So a squared equals 9 gives us a equals 3. And we know b squared is going to be 4, which is the smaller, which means b is going to be 2. So that gives us our major minor. We know that that's going to open up kind of this way along the x-axis. And then we need to get c squared. This is where we use the other relationship. A squared plus b squared equals c squared. Remember, and because the foci are inside the ellipse, we know a squared has to be the biggest. That's going to give us 9 equals 4 plus c squared. C squared equals 5. C is going to be root 5. Okay, to sketch this. Let's sketch this in red again. We have our center at 1, negative 1. So that's going to be our center of the ellipse. And then we're just going to count out 3 to get to the vertices. 2, 1, 2, 3. That's going to be our first vertex. 1, 2, 3. That's going to be our second vertex. And then to get our major and minor, we just count up 2, 1, 2, 1, 2. And that looks like it's going to be our sketched ellipse. The vertices of this ellipse would be, we're going to take the x-coordinate of the center, and we're going to add and subtract 3. That would be our 2 points. And then let's just find the foci real quick here. We know that we have to go plus or minus root 5 from the center. So I'm going to do the same thing. I'm going to go 1 out in the x direction, and I'm going to add root 5 to get one of them. And then I'm going to subtract root 5 to get the other foci. Root 5 is just a little over 2, so we can see that the foci, I'm going to do that in green here, would be kind of right there. So if we're going to draw the string, oops, that was terrible with the string there. Sorry about that. If we're going to draw the string, that's where the string would connect, is on, between the 2 foci to the edge of the ellipse.